Oh, hello. Let's do some lead coding practice. Um, we did the two some question yesterday. Today we'll try to do something else. Let's try to do. Um, yeah, let's try to do this valid anagram question. Valid anagram. Oh, not the neat code side. I want the lead code side. Yes. Okay. Given two strings S and T, return true if T is an anagram of S and false otherwise. S and T. Okay. Anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using the original letters exactly once. S and T should contain the same letters and the same frequency of letters. Am I right? Using all the original letters exactly once. Yeah. So the same letters and the same frequency of letters. Instantly, when I hear frequency, I think of using the hash table to hash map to count the frequencies of the the characters. Um, so hash we can count the right. We can just count the frequency with the hash map. So yeah, one way of solving this that I can say that first we'll just count the number of characters we have in this S string, right? So let me try and explain this. So we have this anagram string, right? S is anagram, T is Nagarvam. Can I copy paste it? No. Okay. Can I take a screenshot? I think I can paste it. Right. Yeah. So we have as is anagram, right? I'll try to explain it. So we'll have this hash map. Fuck. Sorry, no swearing. Um, okay. Yeah, we'll have this hash map. Oh my god. Make this thick. Oh no. Alright, fine. Uh, this hash map. Okay. So S. So we'll go through the string through the characters one by one. So we find A. A will be one. Then we have N. N will be counted as one. Then we have A again. A will be two now. We have G now. Would be one. We have R. R would be one. We have A again. A would be three. We have M. M would be one. So we have saved this information in the hash map, the frequency of each characters that we have in the S string. Now the T string also needs to have the same characters and the same frequencies that the S string has. So now if we go through the T string and then as we count the letters, we subtract it from here. So say suppose now N, we go through this string character by character. So N, so N would make this hash map ka frequency 1 से 0. So now this n's frequency is 0. The yeah, and the ideal hash map now should look like ki every element of the hash map should have 0 as the frequency. So we have A here. So we'll subtract the A's frequency by 1. We have G here, subtract G's frequency by 1. We have A again, subtracts A frequency by 1. We have R's frequency by 1. Then we have M's frequency by 1. So sorry, that's A also. Then this frequency is 1. So you can see that every character's frequency is now reduced to 0. And this is what the ideal so this is what the ideal hash map should look like if S is the anagram of T. If T has any extra elements than S, then this would show like -1 or -2 somewhere. And if S has more elements than T, then it would be like 1 or 2 somewhere that you can see. So let's try to code this. Right. We need a hash map. So let's create a dictionary. Right. Mm, okay. So let's go through elements of S first. For I in S, so we'll go character to character from the S string. Right. So if so, dict1 of I is 1 if I not in dict1, else dict1 of I plus 1. So basically, if the current character in the string, if it's not in the hash map, then initialize the uh, hash map by 1, or else just add it to the previous value. So if you have seen, right, the first time we got an A, we initialized the A by 1, and then since the A is already there, then we'll just add to the current value of A. So 1, then 2, then 3. This is what we'll do, right? Yeah, that's all we need from S. Then we'll iterate through the elements of T. Um, dict1 of I is equal to mm, okay. Let's do a different if here. If I if I not in dict1, right? So the T string brings a new element, completely new element. So that means that this S and this T are not same. Na, suppose this anagram and nagaram. Suppose this nagaram had uh, a D inside this string, but then S does not have the D, right? So what we'll do, we'll return false right away. We'll not continue with the program, right? Else we have the string there, then we'll subtract the value by 1. Okay, subtract the value by 1, and if the value reaches 0, um, yeah, if dict1 of I is 0, then is it dict1 dot remove? One second. Oh, it's delete. Delete dict1 of I. So what I'm doing, right, if the frequency has reached 0 already, then just remove the element from the dictionary. So what we want now, in the ideal scenario, that the dictionary should be empty, completely empty, right? And if Yeah, complete. It should be completely empty. So, and also let's add one another condition, that if the lengths are not same, if S and T has different lengths altogether, then we should not continue with the program only. We should stop right there. Yeah, just return false. So we don't have to do everything all over again. Okay. If we have done everything, right? If we have done everything, okay. Return length of dict1 equals 0, which means that if the dictionary has nothing in it, then it will return true, which means that they are anagrams. And if dictionary still has any elements, then it should return false. Let's see. Oh no, why is it returning false? Okay, anagram, nagram, output false, expected true. This is false, this is returning false, right? Length of dict1. Okay. Um, let's try to debug this. Where is it going wrong? This is not. This won't go wrong here. That I know. Uh, this is just adding the frequency. Let's print our dict here to see. For I in T, if I not in dict one, yeah, then it should return false. Let's print 2 here just in case if it comes in this block. Else dict of minus 1. Okay, and let's print dict1 here. I'm printing this so that I can see at what stage what the values. What? Why is it not printing dict1 at all? Huh? It did not print only. So it's going out here. If length, oh, not equal to. Oh my god, I'm so stupid. If it's not equal to t, right? You can use this, right? Huh? I can use this, I think. Okay, fine. Fair enough. So, see, it counted the frequency of S here. So, we printed the dict one here, right? After it has counted every element from S. So, this is how the dictionary looks like. And then we traversed through the whole T, and then we deleted everything if the frequency reaches 0. So, it deleted everything, and the final dict one looks completely empty. That's why it returns true, because the length of dictionary is equal to 0. Let's remove the print statements and submit it. God spend you, God spend you. No singing. We are in an interview. Yeah, nice. So the time complexity of this program would be O of n, because we are looping through S only once and looping through T only once. So that would be O of n, or you can say O of n plus m, because if the length of S and T are different, but then it would get compared here only, right? So this is O of n. And then space complexity, it would be O of n if the dictionary completely fills up. But wait, no, this would be O of 1. Uh, oh no, it's O of n. Okay, it would be O of n, because if the dictionary can get full with the elements in the worst case. So yeah, the space complexity would be O of n, and that's the valid anagram problem solved. Let me know how I did it. Let's go.